What's up, quarantine individuals? It's your math teacher, Miss Sorensen, with video 7, using one trig value to find another. Before we start, we're going to have to do a bit of review, so let's get started. Let's first review the quadrants. So to review the quadrants, watch how I draw my C. I first start in quadrant 1, then I hit quadrant 2, then I hit quadrant 3, then I hit quadrant 4. So labeling this as quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Please notice that quadrant 1 is from 0 radians to pi over 2. Quadrant 2 is from pi over 2 to pi. Quadrant 3 is from pi to 3 pi over 2. And lastly, 3 pi over 2 to 2 pi for quadrant 4. Now let's talk about the trig values and what their signs are for each. So I want you to write sine, cosine, and tan for all 3 quadrants. And just a little shorthand here. And I care about their signs. Are they positive or negative? Well, first of all, when we're talking about coordinates on a unit circle, our sign is always the second coordinate. So we're looking at the signs of the blue. So we can see here that the blue coordinates are positive, the blue coordinates are positive, the blue coordinates are negative, the blue coordinates are negative. So that was for sine. Now let's go ahead and let's deal with cosine. Cosine, of course, are the red coordinates, the first coordinates. So here we've got a positive, here we've got a negative, here we've got a negative, here we've got a positive, and let me go ahead and erase these. And now let's talk about tangent. Tangent, of course, as a review, tangent is equal to sine over cosine. So I'm just going to take these two signs and divide them. What is a positive over a positive? Yeah, of course, it's a positive. That's a T for tangent. Okay, how about a positive divided by a negative? That's a negative. Negative over negative is a positive. And a negative divided by a positive is a negative. How are we going to memorize this? That's not hard, but it takes quite a bit of time to do that. So let's use a little hint here. Let's highlight the things that are always positive. All right, here we're going to use a mnemonic device called all. Oops, let me do that again. All students take calculus, which I hope is true if you're a junior or a sophomore this year and you're taking pre-calc. I'm hoping that you're taking calc with me next year. So why did I write all students take calculus just like I would write quadrants 1, 2, and 3? Well, I care about the A, the S, the T, and the C. This basically means all are positive. So here A stands for all are positive. However, here just the S, notice there's an S here, just the S is positive. Here just the tangent is positive. That's why we've got T for take. And lastly, in this quadrant 4, we only have cosine being positive, hence C for calculus. Okay, so memorize all students take calculus, or you could just think about where something is and which quadrant and what the signs are going to be. All right, before we move on, I also want to review drawing reference angles. What do I mean by that? Well, in quadrant 1, what does a reference angle look like there? Well, the reference angle is going to be this angle right here, which you should have seen in the review slide. All right, how about the other ones? Well, here in quadrant 2, that would be our triangle. That would show us that our reference angle is approximately right here. And then same thing here, except we're slightly like that. And my reference angle would be from the x-axis down to the angle right there. And last last but not least, we've got our quadrant 4. There's our reference angle, and this would be right here. That's all going to be useful for this new topic coming up right now. All right, here's our first question. So the topic is using one trig value to find another one. So this is telling you what's sine x if tangent of x equals 2. So you can see here that this is the one they're giving us, and this is the one we're trying to find. The other really important thing that I want to highlight is that we need to think about where are we located, and this is really important for the sign of our solution. Well, where is 0 to pi over 2? Our 0 to pi over 2 is located in quadrant 1, is it not? And so I can erase this, and I can go ahead and I can draw my triangle in quadrant 1. Why? Well, because it's telling me that we're between 0 and pi over 2. So I'm going to draw my triangle, just like that. And we know that our x is right here. That's our reference angle. And we're told the tangent of x is equal to 2. Well, what is 2? It's 2 over 1. What is tangent? It's opposite over adjacent. So here, I'm going to go across from x. This is my what? Right, it's my opposite. So here, my opposite, I'm being told, is 2. So I'm going to write that 2 there. Now I'm going to label my adjacent. What's my adjacent side? Oh, I'm being told right here that my adjacent is 1. I want to encourage you to stop right here and make sure that this is correct in terms of positives and negatives. If I'm going to the right one, should that be positive? Well, yes, it should. If I'm going up 2, should that be positive? Yes. So I'm in good shape here. The other problems are going to be a little more challenging than that, so we'll make sure we take a look at that later. Now I want to find what this hypotenuse is. So I'm going to go ahead and do Pythagorean theorem. So I'm going to do 1 squared plus 2 squared equals my hypotenuse squared, and I'll call that x squared. So that's going to be 1 plus 4 equals x squared. It's going to give me a 5 equals x squared. And of course, I get square root of 5 is equal to x. So let's go ahead and label our hypotenuse right here as square root of 5. Now, what was this asking for originally? Well, it was asking for the sine of x. So I need to make sure I answer that question. And we've got sine of x is equal to opposite over hypotenuse. Well, what is sine? It's going to be my opposite, which is my opposite here over my hypotenuse, square root of 5. All right, so this is going to be my opposite of 2 divided by root 5. Almost done. What's the issue with that? Yeah, you're exactly right. We need to rationalize our denominator. So I'm going to take this and have 2 over root 5 being multiplied by root 5 over root 5, which gives me 2 square root of 5 over 5. Is that a good enough answer? Sure is. So we've got a final one of sine of x equals 2 root 5 over 5. Now, am I ready to circle that and say that's my answer? Not really, right? I need to make sure that I have the correct sign for my sine of x. So just a reminder here, all students take calculus, meaning here, all of my sine, cosine, and tan should be positive. All right, so I should have a sine which is positive. Do I have that? Yes, I do. Do I have my answer? Yes. All right, let's move to our next problem, maybe a little bit more challenging. All right, here we go. Secant of theta is equal to 13 over 5. I want you to find tangent of theta and note where we're talking. Think about what quadrant is that in. I'm going to challenge you to pause this video and see if you can set it up. All right, I'm back. We're going to go ahead and see if we can do this. First of all, we have to identify where that is. Where'd you say? First, second, third, or fourth quadrant? Well, if you said that it was in the fourth quadrant, you are correct. All right, so this should be right down here. We practiced drawing our triangles earlier, so it's going to look something like this. And here we've got a theta, so I'm going to put a theta in here. And now secant theta is equal to what over what? Well, secant is h over a, so I've got my h over a is going to be equal to 13 over 5. So over here, I've got my adjacent is going to be 5, and I've got my hypotenuse is going to be 13. Now, how do I label my 5? Well, 5 is going to be positive, correct? Because I'm going to the right. And then I need this here is going to be a negative because I'm going down. And so if I do my Pythagorean theorem, I've got 5 squared plus x squared, because I'm looking for a leg this time and not a hypotenuse, equals 13 squared. That gives me 25 plus x squared equals 169. Subtract 25 from both sides. You're going to find that we get an x squared equals 144. Square rooting both sides, I get x equals 12. Again, what type of 12? Well, remember, we are going right, so that's positive, and down, which is negative. Keep in mind, our hypotenuse from Pythagorean theorem will always give us a positive. But we do care about this sign, and it's negative because it's going down. Now, if you mess that up, it's not a huge deal because we can kind of check that at the very end to make sure our sign is correct. So I wouldn't worry too much about it, but it is helpful. All right, let's answer the question. It wants tangent of theta. Tangent of theta is opposite over adjacent. Well, my opposite is going to be here, and my adjacent is going to be here. So I'm going to get a negative 12 over 5. Let's check that our sign is correct. Remember, all students take calculus. So here, only what is positive? Only cosine is positive. So sine will be negative and tangent will be negative. So do we have our correct answer? Why, yes, we do, because our tan is negative. All right, again, I'm going to encourage you to pause the video and see if you can do this on your own. See if you can set it up. All right, let's make sure you got this right. I'm going to draw my coordinate grid right there, and I'm going to emphasize the fact that we've got this, pi to 3 pi over 2. Where's that located? If you said the third quadrant, you are correct. So I'm going to draw my triangle, which we reviewed how to do that. I'm going to put my theta in here. And remember, tangent of theta equals 3 over 7, which is our opposite over our adjacent. So my opposite is going to be 3, and my adjacent is going to be 7. Well, what are the signs? If we look here, we're going left 7, down 3. So both of them are going to be negative. Again, if you don't get that right, it's not a huge deal because we can check our answer at the end. All right, we need our hypotenuse. So we've got 3 squared, actually technically a negative 3 squared, plus a negative 7 squared equals my hypotenuse squared. That's a 9 plus a 49 equals x squared. That's going to give me 58 equals x squared. And I'm going to square root both sides to give me square root of 58 equals x. And I did check that's not reducible, so I'm just going to write square root of 58 here. All right, let's go ahead and find the final answer. We need to find cosine of theta. Of course, cosine theta is adjacent over hypotenuse. So cosine of my theta is my adjacent over my hypotenuse, or in this case, a -7 divided by the square root of 58. Let's check that this is correct in terms of signs, and then let's deal with rationalizing the denominator. All students take calculus. So the only thing that should be positive here is tangent should be positive. So sine should be negative and cosine should be negative. Is that the case here? Yes, it is. Is that our correct answer though? Technically, yes. However, we need to rationalize the denominator. So let's go back and let's do that. So this is going to be -7 over the square root of 58 times the square root of 58 over the square root of 58. What does this leave us with? -7 square root of 58 divided by 58. Now we have our final answer. All right, here we go, folks. Very last problem on video 7. Again, pause the video, see if you can do this problem on your own. All right, welcome back. You should have realized that this right here is quadrant 4. So your triangle should be here. Here we've got a 12 and a -5 doing Pythagorean theorem, which we've already done for this particular one. I believe we get a 13. That doesn't make any sense. Sorry about that, folks. We can't have a hypotenuse that is shorter than that, so I'm going to erase this. No big deal. Let's make sure I've labeled these sides right. Tangent of theta equals -5 over 12. That's opposite over adjacent. So I should have had my -5 here. All right, no big deal. That means I should have had a 13 here. And that makes much more sense, right? That my hypotenuse is bigger than my two sides. All right, next up is we need to find all trig values. Well, that sounds overwhelming, but not too bad. Sine of theta, cosine theta, and we've already got our tangent theta. Then I'm going to have over here cotangent theta, cosecant theta, and secant theta. Sine of theta is going to be opposite over hypotenuse. In this case, it's going to be, again, here's my angle, -5 over 13. Cosine theta is adjacent over hypotenuse. That's going to give me 12 over 13. Cotangent is going to be the reciprocal of my tangent. So I'm just going to write that. You can see here what my tangent is. So I take the reciprocal of that and get 12 over -5. You can put the negative anywhere you'd like. And then here we've got a 13 over -5, and here we've got a 13 over 12. Let's make sure that our signs make sense. All students take calculus. The only thing that should be positive here is my cosine, and likewise the reciprocal of my cosine as well. All right, ladies and gentlemen, that's it for video 7. Thanks for watching, and make sure you subscribe to the best math videos out there. I hope you're having a great quarantine-cation and doing lots of math. Thanks again.